We are going to review the concept of average atomic mass by completing a short lab activity. Just as a reminder before we get started, you do not need to buy Chex Mix and perform this lab on your own. Follow along with the video and use the data I collect. Most elements in nature occur as a mixture of isotopes. Take the iron atoms in this paperclip, for instance. Most of the iron atoms making up the paperclip are iron 56, but there are a handful of iron 57 and iron 58 atoms as well. The weighted average atomic mass of an element can be determined from the atomic mass and the relative abundance of each isotope. In this activity, you will model the isotope of the imaginary element Snackium, which is just regular Chex Mix. Just as there are different iron atoms in this paperclip, each different piece of Chex Mix represents a different isotope of the imaginary element Snackium. The measurements you make will be used to calculate a weighted average mass that represents the average atomic mass of our imaginary element. On the lab, you are asked to list the steps for solving an average atomic mass problem. I figured it wouldn't hurt to work through another example using neon while talking about the steps. The first step is to convert the abundances from percentages to decimals. This only has to be done if the abundances were given as percentages. Some of you have struggled with this step. Remember, to do this, all you have to do is divide the percentage by 100, which is the same as moving the decimal point 2 places to the left. So the abundance of neon 20 would be 90.48 divided by 100, which equals 0.9048. Now these next two abundances allow me to address errors that quite a few of you are making when completing this step. The abundance of neon 21 is 0.27%. I know that percentage is already very small, but you still have to divide by 100. And when you do that, you get 0.0027. Remember, move the decimal 2 places to the left. The abundance is not 0.27 or 0.027. That was a common mistake on the practice problems. Likewise, with 9.25% for neon 22. When you divide by 100 or move the decimal place 2 spots to the left, you get 0.0925. I saw plenty of mistakes when working with a percentage between 0 and 9. Just make sure you move that decimal place 2 spots to the left. Step 2 involves multiplying the abundances for each element by the mass for each element. For this example, take the abundance of neon 20, 0.9048, times the mass of 20. You should get 18.096. Repeat the process for neon 21 using the abundance and mass, 0.0027 times 21, which is 0.0567. One more time for neon 22, abundance times mass would be 0.0925 times 22, which would be 2.035. In step 3, you add these values together to get the average atomic mass. So 18.096 plus 0.0567 plus 2.035 equals 20.1877 atomic mass units. Step 4 is then to round the answer to the hundredths place, 2 decimal places. Our final answer is 20.19 AMU. I know you probably think you are done, but there is one more very important step. Check your answer on the periodic table. You have an advantage when doing average atomic mass problems. The answer is on the periodic table. Always check to make sure the answer you calculated is reasonable. We calculated an average atomic mass of 20.19. Looking at the periodic table, we can see that neon has an actual average atomic mass of 20.18. Yes! That is pretty darn close. We did the problem correctly. Okay, let's apply this to our imaginary element, Snackium. From the procedure, you can see the first 2 steps involve dumping out the Snackium and organizing the different isotopes into groups. So you can see I organized all the different types of Chex Mix into individual piles. Remember, each snack piece represents an isotope of our Snackium element. Now we need to count the number of snack pieces in each group. There are 49 corn checks, 72 wheat checks, 17 square pretzels, 11 circle pretzels, 18 breadsticks, and 7 rye pieces. This data needs to be recorded into the data table. Once again, you should copy this data into your lab. There's no reason for you to buy Chex Mix and do this lab on your own. After you copy the number of pieces data, you should add them up to find the total number of pieces. There are 174 total snack pieces. We will be using this data to determine the abundance of each snack piece isotope in just a second here. To calculate the average atomic mass of the isotope, we also need the mass of each snack piece. I completed step 4 of the procedure by finding the mass of one piece of each snack item using a balance. A corn Chex has a mass of 0.49 grams. Wheat Chex, 0.66 grams. The square pretzels have a mass of 1.10 grams, while the circle pretzels have a mass of 0.93 grams. The breadsticks have a mass of 0.75 grams, and the rye pieces were the most massive isotope with a mass of 1.49 grams. Make sure you are filling out your data table. The next step in the procedure is to calculate the abundance of each snack piece. To do this, you take the number of each snack piece divided by the total number of snack pieces. I recommend rounding these answers to the hundredths place, 2 decimal places. So we had 49 corn Chex and a total of 174 pieces. The abundance of corn Chex would be 49 divided by 174, which is 0.28. The same process can be repeated for all the other isotopes of Snackium. There are 72 wheat Chex, so the abundance of wheat Chex is 72 divided by 174, which is 0.41 when rounded to 2 decimal places. Notice that the abundances are already in decimal form. 28% of the Chex Mix is corn Chex, 41% is wheat Chex. We didn't change it to percent, it's already in decimal form, which means there's no need to divide the abundances by 100. This is where you should pause the video and finish the abundance calculations for the data table. If you add up all of these abundances, you should get 1 or very close to 1. You will know you are on the right track if you add these abundances and get 0.99. All right, the next step in the procedure is to multiply the mass of each isotope by the abundance. This is as simple as multiplying the number in the mass of one piece column times the number in the abundance column. For corn Chex, you multiply 0.49 times 0.28 to get 0.1372. Wait to round these values until the end. For wheat Chex, you would take 0.66 times 0.41 to get 0.2706. Once again, this is where you should pause the video and complete the calculations on the data table. The final steps in determining the average mass of our imaginary element, Snackium, would be to add up the weighted averages and round the answer to 2 decimal places. That value will go in the box in the bottom right corner of the data table. The units on your answer should be grams. Now we can't check our work on the periodic table because Snackium is not real. However, we can check to see if our answer makes sense. The lightest isotope of Snackium was the corn Chex with a mass of 0.49 grams. And the heaviest isotope of Snackium was the rye chips with a mass of 1.49 grams. So the average atomic mass should be between 0.49 grams and 1.49 grams. You can probably get even a little more accurate with your estimate. Since 41% of the Snackium consists of the wheat Chex isotope, I bet the calculated average atomic mass is fairly close to 0.66 grams. All right, there are a few post-lab questions that you need to work through in order to finish this review lab. Be sure to follow the steps for solving average atomic mass problems. If you do that, you can't go wrong.